Welcome back, everyone, to the Deep Dive. Ready for another wild ride? Today, we're going to be diving into, well, this is a fascinating book, Uncovering the Missing Secrets of Magnetism by Ken L. Wheeler. And I'm really excited about this one.
Yeah, I think this one's going to be really popular with our audience. They're already pretty well versed in magnetism, so going even deeper with this is going to be awesome.
Yeah, for sure. And if you love this kind of deep dives into the unknown, hit that like button and subscribe to the channel. We've got tons more mind-blowing content coming your way. But okay, so this book, it's not just about like the basics of magnetism. Ken Wheeler, he's got some seriously out there ideas, like really different ways of thinking about magnets.
Yeah, he's not messing around. He's basically trying to redefine how we understand magnetism at the most fundamental level.
Okay, so let's jump right in. What's the biggest, most mind-blowing idea that he throws at us right out of the gate?
Well, he says that magnets, they're not primarily about magnetism. It's all about something called dielectricity.
Electricity. I'm already lost.
I know, right? It sounds pretty intimidating at first.
Yeah, it's not exactly a word you hear every day.
Definitely not.
Yeah.
But it's actually not as complicated as it sounds once you wrap your head around it.
Okay, so ELI5. Explain it to me like I'm 5 years old.
All right, so imagine you have like a mold, like one of those chocolate bunny molds, and you pour liquid chocolate into it.
Okay, I'm with you so far.
So you get a chocolate bunny, right? Well, Wheeler is saying that dielectricity is like an invisible mold that shapes the magnetic field.
Whoa. Okay, so it's like this invisible force that's guiding how magnetism behaves.
Exactly. It's like a hidden blueprint that determines the structure and flow of magnetic energy.
So where does this invisible mold exist? Like, is it just floating around in space?
That's the really trippy part. Wheeler says it exists in something he calls counterspace.
Counterspace, is that like another dimension or something?
Kinda, yeah. It's like a mirror image of our familiar three-dimensional world.
Whoa, okay. My mind is already starting to bend a little bit here. So we're talking about a force that exists beyond our normal understanding of space. And it's shaping how magnets work in our world.
That's the basic idea. It's a tough concept to grasp, I know.
It is. But it's also super intriguing.
Right. It's like we're being asked to consider a whole new layer of reality.
Okay, so let's try to connect this back to magnetism. How does this dielectricity, this invisible mold in counterspace, how does it actually relate to what we see magnets doing?
Well, Wheeler believes that magnetism is actually a manifestation of dielectricity. He says humanity's been looking at the horse's rear when it comes to magnets.
The horse's rear.
Yeah, it's a pretty vivid image, right? Basically saying we've been focused on the effects of magnetism, but totally missing the underlying cause.
Okay, I see. We've been so caught up in what magnets do that we've ignored the fundamental force that's driving it all.
Exactly.
So what is that fundamental force, according to Wheeler?
He believes there's this background energy field that permeates everything, something he calls the ether.
Oh, the ether. I've heard of that before.
Yeah, it's an old idea in physics. Most scientists kind of abandon it.
Yeah, they went with the whole quantum field theory thing instead, right?
Right. But Wheeler's bringing back the ether. He says that magnetism is how this ether energy expresses itself in a very specific way.
Okay, I'm trying to picture this.
Think of it like this. The ether is like the ocean, and magnetism is a wave on the surface of that ocean.
Okay, I kind of get that. So the ether is this vast energy field, and magnetism is just one way that energy manifests itself.
Exactly.
So if magnetism is just a wave on this ether ocean, what about magnetic attraction? Like when two magnets stick together, what's actually happening there?
This is where things get really interesting. Wheeler says that what we perceive as attraction is actually an illusion.
An illusion? Wait a minute. How can magnets sticking together be an illusion?
Oh, yeah.
You feel that force.
I know, it's a mind bender. But think of it this way. Imagine you have two balloons, and you push them both towards a vacuum cleaner hose.
Okay, I'm picturing.
They're not actually attracted to each other. They're both being pushed into the same low-pressure zone.
Oh, I see.
Wheeler says that something similar is happening with magnets. They're not really being pulled together. They're both being pushed into the same low-pressure zone in this invisible dielectric field.
Okay, so it's not about a pulling force. It's more like they're being guided by this unseen field and pushed into these specific spots.
That's a great way to put it.
This is definitely making me rethink everything I thought I knew about magnets.
It's a whole new perspective, for sure.
So this dielectric field, is it like uniform throughout space? Or are there like variations and structures within it?
That's a great question. And it leads us to another one of Wheeler's key concepts, the dielectric inertial plane.
Oh, yeah. I remember seeing that in the book.
He describes it as the equator of a gravitational sphere.
The gravitational sphere. Okay, now you're really blowing my mind.
It's basically like an invisible boundary within the magnetic field, where the dielectric forces are at their most intense.
Okay, I'm trying to visualize this dielectric inertial plane, but I need a visual. What does it actually look like?
Have you ever seen those iron filings sprinkled around a magnet?
Yeah, they make those cool patterns, right?
Exactly. They form those curves and lines that seem to radiate out from the magnet. Well, that pattern is actually showing you the influence of the dielectric inertial plane.
Whoa, no way. So those iron filings are like a window into this unseen world.
Precisely. It's like the plane is a blueprint, guiding the flow of magnetic energy and shaping those iron filings into those specific curves.
So those filings are actually giving us a glimpse into this hidden force of dielectricity.
That's what Wheeler's saying.
That's amazing. It's like we're seeing the invisible made visible.
And he takes this even further. He uses another visual demonstration with a device called a Ferrocell.
A Ferrocell, what's that?
It's this device that allows you to see magnetic fields using light.
Wait, you can actually see magnetic fields?
You can with a Ferrocell.
Yeah, okay, I'm definitely intrigued.
So basically, it's like a thin layer of this special liquid that reacts to magnetism, sandwiched between two pieces of glass.
Okay.
And when light passes through this liquid near a magnet, it creates these amazing visual patterns that reveal the shapes and movements of the magnetic field.
I'm trying to picture this. What kind of patterns does it show?
You see these beautiful swirling shapes called hyperboloids. They look like double-curved funnels or hourglass shapes.
So like three-dimensional patterns.
Exactly. And Wheeler believes that these hyperboloid shapes are a direct reflection of the underlying dielectric field geometry, the structure that guides the behavior of both magnetism and light.
Wow, so these aren't just pretty patterns. They're clues to the fundamental nature of energy and light itself.
That's what Wheeler is proposing.
This is seriously blowing my mind. It feels like we're peering behind the curtain of reality, seeing these invisible forces that shape our world.
And this is really just the tip of the iceberg. There's so much more to explore in Wheeler's model.
I can't wait to dive deeper.
Let's take a break, and then we'll come back and talk about how he explains the creation of magnets and how they actually work according to his model.
Sounds good to me. This is definitely a deep dive. I don't want to rush through.
All right, so before we jumped into all this, you mentioned that some of the stuff you've been looking at talks about how magnets are actually formed.
Oh yeah, there's all this stuff about magnetic domains inside materials like iron.
Yeah, so the basic idea is that these tiny domains are like mini magnets.
Right.
And when you magnetize something, you're basically aligning all these domains in the same direction.
Yeah, that's what I always thought. Like you apply a strong magnetic field, and it forces all those little domains to line up, creating a bigger magnet.
Right. That's the conventional explanation. But of course, Wheeler has a completely different take on this.
Figures. So what does he say?
He says it's not about aligning domains at all. He believes magnets are created through a process of electrification.
Electrification. Hold on. Isn't that just about adding or removing electrons from something?
Right.
So how does that create a magnet?
Wheeler says that when you electrify a material, you're actually increasing its dielectric potential. Remember that invisible mold analogy we talked about?
Yeah, the chocolate bunny mold.
Right. So it's like you're pumping more energy into that mold, causing it to expand and exert a stronger influence on the surrounding space.
Okay, I think I'm following. So it's like electrification is supercharging the dielectric field around the material.
Exactly. And Wheeler calls this dielectric saturation.
Dielectric saturation.
It's like if you take a clay sphere and you squeeze it, all the clay gets forced outward, creating this bulge.
Okay.
And that bulge is the magnetic field, taking on that hourglass or dumbbell shape we saw in the Ferrocell.
Oh, wow. I see. So instead of aligning tiny magnets, we're essentially inflating this dielectric field around the material. And that creates the magnetism.
You got it. It's a pretty radical departure from how we typically think about magnets.
Yeah, it definitely is.
Yeah.
But it makes sense in the context of Wheeler's model.
Right. It all fits together.
Okay, so there's something else I wanted to ask you about. Bismuth?
Ah, yes.
Wheeler seems to have a special fascination with this element.
He does. He even calls it the dielectric superstar in the book.
So what's the deal with bismuth? What makes it so special?
Well, first of all, it's incredibly diamagnetic.
Diamagnetic.
Meaning it repels magnetic fields.
Wait, it repels magnets. I thought opposites attract.
I know, right? It seems counterintuitive.
It definitely does.
But bismuth is like the ultimate rebel when it comes to magnetism.
I like that, the rebel element.
And the reason it's so diamagnetic is because of its incredibly high dielectric inertia.
Okay, more new terms.
Yeah.
Dielectric inertia. Break that down for me.
All right, think of it like this. Imagine you have a heavy bowling ball and a lightweight tennis ball.
Yep.
If you try to push both of them with the same force, the tennis ball will move much more easily, right?
Yeah, because the bowling ball has more inertia.
Exactly. It has more resistance to change in motion. Well, bismuth is like the bowling ball of the dielectric world.
So it's super resistant to changes in the dielectric field.
Exactly. And that resistance is what makes it so diamagnetic. It's like it's saying, nope, not going to budge magnetic field. You can't push me around.
That's a great analogy. So bismuth is basically the heavyweight champ of dielectric inertia.
You got it. And this high dielectric inertia also explains some of bismuth's other unique properties. For example, it's a terrible conductor of electricity and heat.
Really? So it resists magnetic fields,
Hmm.
electric currents, and heat flow. Bismuth is a fortress of inertia.
Pretty much. And on top of all that, it also forms these incredibly beautiful and complex crystal structures, unlike any other element.
I've seen pictures of those bismuth crystals. They're stunning.
They are. And Wheeler believes these structures are a direct expression of bismuth's powerful dielectric nature.
Okay, bismuth is officially on my list of favorite elements now. It's like
Oh.
the underdog of the periodic table,
Yeah?
defying all expectations.
I know, right? And Wheeler thinks bismuth has a ton of unrealized potential.
Like what?
Well, he even hints at the possibility of using it for things like anti-gravity technology.
Anti-gravity. Now that would be a game changer.
It definitely would. But even if we don't end up levitating cars with bismuth, Wheeler believes it has enormous potential for new inventions and breakthroughs, especially in energy generation.
I can see why he's so fascinated by it. Bismuth is like a window into this unseen world of dielectricity.
He really is.
Okay, so we've talked about dielectricity, this invisible mold in counter space.
Yeah.
We've talked about the dielectric inertial plane, and we've talked about bismuth, the dielectric superstar. What else does Wheeler throw at us?
Well, we can't forget about how he challenges the conventional understanding of light.
Oh yeah, he completely throws out the whole wave-particle duality thing.
Right.
And he even says photons don't exist the way we think they do.
Exactly.
Which is a pretty big deal considering how much of modern physics is based on the idea of photons.
It is a huge shift in perspective, and it all ties back to his model of dielectricity.
Okay, so how does light fit into all of this?
Wheeler believes light is not a wave or a particle, but a electromagnetic phenomenon.
Electromagnetic, that's a mouthful.
It is. But basically imagine a cable with a central dielectric core surrounded by a spiraling electromagnetic field.
Okay, so light is like a tiny self-contained energy cable zipping through space.
That's a great way to visualize it.
And this model explains how light can travel through a vacuum.
Right, because it's not a traditional wave that needs a medium to propagate through.
Okay, that makes sense. But if light isn't made of photons, how does he explain things like the photoelectric effect? You know, the thing that Einstein explained with the idea of photons knocking electrons loose?
That's a great question. And it's where Wheeler's model gets really interesting. He reinterprets the photoelectric effect in terms of dielectric discharges. Remember how we talked about electrification increasing the dielectric potential of a material?
Like pumping energy into the mold.
Right. Well, Wheeler believes that light, with its dielectric core, can cause similar discharges in certain materials.
So instead of a photon colliding with an electron, it's more like the dielectric core of the light is giving a jolt to the electrons, causing them to go free.
Exactly. It's a subtle but crucial difference in perspective. Wheeler is essentially saying that the photoelectric effect is driven by the dielectric component of light, not by discrete particles called photons.
Wow, that's a really different way of looking at it.
It is.
And it ties back to his whole idea of dielectricity being this fundamental force that underlies everything.
Exactly.
Okay, my mind is officially blown. This is seriously making me rethink everything I thought I knew about light and energy.
I know, it's a real paradigm shift.
It is.
And Wheeler doesn't stop there. He goes on to describe 6 fundamental types of waves, 3 transverse and 3 longitudinal, that he believes are responsible for how energy propagates through the universe.
6 different types of waves.
Yep. And they're all based on his model of dielectricity and how it interacts with the electromagnetic field.
Okay, that's a lot to process.
It is. But it's all part of his grand vision of a universe governed by dielectricity.
So he sees the dielectric field as the primary actor, the driver of both electrical and magnetic phenomena.
Exactly. And those 6 wave types are the tools it uses to orchestrate the symphony of energy we see all around us.
This is seriously mind-blowing stuff. I'm starting to see the world in a whole new light.
Me too. It's incredible how Wheeler's model opens up so many new possibilities and makes you question everything you thought you knew.
It really does.
And he ties all of this back to the ether, that mysterious medium that physicists used to believe filled all of space.
The ether. So he's bringing back an idea that science had basically abandoned?
He is. But his concept of the ether is a bit different from the classical view. He sees it as the fundamental substrate of reality, the source of all energy and matter.
So it's like the canvas upon which the universe is painted.
Exactly.
So dielectricity is the paintbrush.
That's a great way to put it.
Wow. Okay, I'm trying to wrap my head around all of this. So we're saying that the ether is real, and it's this dynamic, energetic field that gives rise to everything we see and experience.
That's the essence of Wheeler's model.
This is seriously heavy stuff.
It is. It's a bold and challenging perspective.
It definitely is.
But it has the potential to unlock so many of the mysteries that have puzzled scientists for centuries.
I can see that.
And it all stems from his unconventional understanding of magnetism and the fundamental role of dielectricity.
Well, I think we need to take another break. My brain is about to explode.
Mine too. Let's come back in a few minutes and try to summarize everything we've learned and talk about where we go from here.
Okay, are we ready to try and wrap our heads around all of this?
Yeah, I think so. My brain is still buzzing from all that stuff about dielectricity and the ether.
I hear you. It's a lot to take in.
It really is. But it's also incredibly fascinating. Like, we've been given a glimpse into a whole new way of understanding the universe.
Absolutely. And even if you don't agree with everything Wheeler says, his work is so thought-provoking, it forces you to question everything you thought you knew.
That's for sure.
Yeah.
So let's try to summarize what we've learned. Where do we even begin?
Well, the most important takeaway, in my opinion, is that Wheeler sees dielectricity as the fundamental force at play, not magnetism. Right, it's like magnetism is just the tip of the iceberg.
Exactly. It's a thing we can see and measure, but it's just a surface expression of this deeper force. Dielectricity is the puppet master, and magnetism is just the puppet dancing to its tune.
I love that analogy. It's so visual. And it helps me understand how something invisible can be so powerful.
Yeah, and remember that invisible force is shaping the magnetic field from behind the scenes, using that invisible mold we talked about.
The one that exists in counterspace.
Right, and that mirror image of our three-dimensional world.
Which just adds another layer of mind-bending complexity to the whole thing.
It really does. Wheeler's basically saying that there's more to reality than we can perceive with our senses.
Yeah, that there's this whole other dimension out there influencing our world.
And that's where things start to get really trippy.
They do. And then there's the fact that what we experience as magnetic attraction might be an illusion.
Right. It's not that magnets are actually pulling towards each other, but they're both being pushed into these low pressure zones in the dielectric field.
Like those two balloons being sucked towards a vacuum cleaner hose.
Perfect analogy. They're not attracted to each other, but they're both being influenced by the same force, moving towards the same point of lower pressure.
Wheeler calls this counterspatial avoidance, right?
He does. And it's a completely different way of understanding how magnets interact.
It makes you realize how much we take for granted. Like we see magnets sticking together and we think, oh, that's just magnetism. But there might be a whole lot more going on beneath the surface.
Absolutely. And then we have that mysterious dielectric inertial plane.
Oh, yeah, that invisible boundary that seems to be shaping the behavior of magnetic fields.
Right. Wheeler describes it as the equator of a gravitational sphere, a zone of intense dielectric force that guides the magnetic field and influences how it interacts with other fields.
And we can actually see the effects of this claim in those iron filing patterns around a magnet.
Exactly. Those patterns are a visual representation of the dielectric inertial plane, giving us a glimpse into this unseen world of forces.
It's like those iron filings are a secret code. And Wheeler has given us the key to decipher them.
I like that. And then, of course, there's bismuth.
Ah, yes, the dielectric superstar.
With its strong diamagnetic properties, its resistance to electricity and heat, and its amazing crystalline structures.
Bismuth is definitely one of the most fascinating elements now that I know a bit more about it.
It's a real testament to the power of dielectricity.
And Wheeler believes it has the potential for some pretty mind-blowing technologies.
He does. From anti-gravity to new forms of energy generation, bismuth could be a game changer if we can unlock its full potential.
And then there's light. Wheeler's model of light is just as radical as his model of magnetism.
Yeah, he completely throws out the wave-particle duality idea.
Yeah.
and says that light is actually a electromagnetic phenomenon.
Like a tiny little energy cable zipping through space.
Right, with a dielectric core and a spiraling electromagnetic field.
And this explains how light can travel through a vacuum.
It does, because it's not relying on a traditional wave that needs a medium to propagate through.
And then there's his explanation of the photoelectric effect.
Not as photons knocking electrons loose, but as dielectric discharges triggered by the dielectric core of light.
It's such a different way of looking at it.
It is, but it makes a lot of sense in the context of Wheeler's model.
It does. And then, of course, we can't forget about the ether.
The fundamental substrate of reality, according to Wheeler. The source of all energy and matter.
The canvas upon which the universe is painted.
Beautifully put.
So basically, Wheeler is saying that everything we see and experience is ultimately an expression of this dynamic, energetic field that he calls the ether.
That's the essence of his model.
This deep dive has been an incredible journey.
I agree. It's been a wild ride through some very challenging concepts.
But I feel like I'm looking at the universe with brand new eyes.
Me too. It's amazing how a new perspective can completely change your understanding of things.
So where do we go from here? What are we supposed to do with all these mind-blowing ideas?
I think the most important thing is to keep an open mind and to never stop questioning. Wheeler's model might not be the ultimate answer, but it shows us that there's always more to learn, and that even the most established scientific ideas can be challenged and reinterpreted.
That's a great point. I think sometimes we get so comfortable with the way we think about things that we forget to question whether there might be other ways of seeing the world.
And that's what makes Wheeler's work so valuable. He's not afraid to challenge the status quo and to push the boundaries of our understanding.
He's definitely a pioneer in that sense. Well, I think we've covered a lot of ground today.
We have, and I hope our listeners are just as excited about this deep dive as we are.
If you enjoyed this mind-bending journey, hit that like button and subscribe to the channel for more deep dives into the unknown. And let us know in the comments what other scientific mysteries you'd like us to explore.
Until next time, keep questioning, keep exploring, and keep that spark of curiosity alive.